Hello everyone and welcome to today's video tutorial. In this video, we are going to talk about the motion of a body on an inclined plane. This lesson is going to be very useful because it is going to help us to really understand how to describe the motion of a body as it moves up and down an inclined plane. To explore the concept, let's consider this free body diagram below. When a body is on an inclined plane, it can move either upwards or downwards. The principles for describing the upward motion of a body on an inclined plane is basically the same for describing its downward motion. When a body moves on an inclined plane, a number of factors or forces act on it. From the diagram, we see that the plane is inclined to an angle theta to the horizontal. We can also identify about 5 different forces that are acting on the body. At any point on the plane, gravity acts on the body, and we know that gravity acts vertically downward. As the body rolls down, a force labeled X from the diagram brings it down. Also, as it rolls up, the same force sends it upwards, but because it is in an opposite direction, the magnitude of the force is minus X. Also, anytime a body is on a surface, a force called the reaction, represented by R, acts on it in order to keep it in equilibrium. From the diagram, this reaction force is extrapolated to obtain the Y. We also see that the angle of inclination, theta, is equal to the angle between the gene and the Y. Now let's apply the concept of vectors to find the expression for X, Y, gene, and theta. We can do that if we separate the diagram into two. So when we separate the part of the diagram that has the X, the Y, and the gene, this is what we would get. From the concept of vectors, we understand that the X and the Y are two vectors that act at a point. And so the resultant of these two vectors will be in between them, which we have labeled the gene. So now let's find an expression for S. We can do that by using the sign ratio. So we see from the diagram that sine theta is equal to X over gene, and for that matter, X is equal to gene sine theta. If we want to find an expression for Y, we will use the cosine ratio, and this gives us cos theta is equal to Y over gene. Making Y the subject, we have Y is equal to gene cos theta. So at this point, let's bring all into a single perspective. When we bring all into a single perspective, we are going to have this diagram. And so we have brought the values of the X, negative X, and the Y into the diagram. As the body rolls up and down the plane, the angle of inclination becomes very important. And so the gene is not just gene, but because we are factoring in the angle, we are going to multiply the gene by the sine of the angle. As the body rolls down, we are going to have gene sine theta, but as it rolls up, because its movement is against the direction of gravity, it becomes minus gene sine theta. At this point, we wouldn't need the gene cos theta, and so we will reserve it when we are talking about forces in general. Now let's proceed to describe the motion of a body on an inclined plane. We can do that by using equations. Here let's visit the equation for describing vertical motion under gravity. If you can remember from our previous lesson, we know that for vertically downward motion under gravity, the three main equations are v is equal to u plus gt. v squared is equal to u squared plus 2gs, and s is equal to ut plus half gt squared. And so in order to obtain the equations for a body moving down an inclined plane, we just have to modify these equations, this time factoring in the angle of inclination. And so by modification, we are going to have v is equal to u plus j sine theta t. Also, we are going to have v squared is equal to u squared plus 2 j sine theta s. And then finally we have s is equal to ut plus half j sine theta t squared. In the same way, if you want to modify the equations to obtain the equations of a motion that is moving up an inclined plane, we are going to have v is equal to u minus j sine theta t. v squared is equal to u squared minus 2 j sine theta s. And then finally, s is equal to ut minus half j sine theta t squared. In addition to these equations, we can come out with two more equations describing the time taken for the body to reach a particular distance as it moves up and down the inclined plane, and then the distance it can move when given a particular initial velocity. If you want to find the maximum displacement or the maximum height the body can reach as it moves on the inclined plane, we are going to use the equation v is equal to u minus j sine theta t. And as the body reaches its maximum displacement or the maximum height on the plane, the final velocity v is going to be 0. And so we can say that 0 is equal to u minus j sine theta t. And by making u the subject, we have u is equal to sine theta t. And then let's make t the subject to get t is equal to u divided by j sine theta. If you want to find the maximum displacement or the maximum height that the body can reach as it moves up the inclined plane, we are going to use the equation v squared is equal to u squared minus 2 j sine theta s. And since v is equal to 0, we are going to get 0 is equal to u squared minus 2 j sine theta s. If we make s the subject, finally we are going to get s is equal to u squared over 2 j sine theta. Alright, at this point we have gone through all the bases of the concepts. So now let's solve some few problems. Our first problem is an inclined plane makes an angle of 45 degrees to the horizontal. A body at rest is rolled down for 10 seconds. Find its A, final velocity, B, distance traveled along the plane, and acceleration due to gravity has been given as 10 meters per second squared. Now let's have a free body diagram to properly analyze this question. So from the diagram, we are told that the body starts from rest. So this means that the initial velocity u is equal to 0 meters per second. And then the body also takes a time of 10 seconds to roll down the plane. Of course, the j is given as 10 meters per second squared. So for the A part of the question, that we are supposed to find the final velocity, we are going to use the equation v is equal to u plus j sine theta t. But we know that the body starts from rest, so the initial velocity is 0. And so we are going to have v is equal to j sine theta t. By substituting in the figures, we are going to have v is equal to 10 meters per second squared times 10 seconds times sine 45 degrees. When you compute this on our calculators, we are going to have 7.07 meters per second. Now let's go to the B part of the question. If you want to find the distance traveled by the ball along the plane, we use the equation s is equal to ut plus half j sine theta t squared. And since u is equal to 0 meters per second, the equation will now become s is equal to half j sine theta t squared. And by substituting in the figures, we have s is equal to half times 10 meters per second squared times 10 seconds squared times sine 45 degrees. When you compute this on our calculator also, we have 353.55 meters. Now let's take our second question. It reads, a ball is thrown up a smooth inclined plane with an initial velocity of 50 meters per second. If the angle of inclination of the plane is 30 degrees to the horizontal, find the A. time taken for the ball to reach its maximum displacement, and B. maximum displacement attained. Here also G has been given as 10 meters per second squared. Let's have another free body diagram to analyze the question. So from the question, the object is now thrown up the plane, and so it will be moving against gravity. So the value of J must be negated, and so from the diagram we have the minus J sine theta. So the A part of the question says we should find the time taken to reach its maximum displacement, or taken to attain its maximum displacement. And so we can use the relation V is equal to U minus J sine theta t, and at the maximum point of displacement, the final velocity V is equal to 0. And so we are going to have U is equal to J sine theta t. By making t the subject, we have t is equal to U divided by J sine theta. If we substitute in the values, we have t is equal to 15 meters per second divided by 10 meters per second squared multiplied by sine 30 degrees. And this gives us t to be 3 seconds. Now the B part of the question, we are supposed to find the maximum displacement attained by the body. And so we use the relation s is equal to ut minus half j sine theta t squared. Let's substitute in the values. We have s is equal to 15 times 3 minus 0.5 times 10 times 3 squared times sine 30 degrees. This will give us 45 minus 22.5. And finally we have s is equal to 22.5 meters. And so that is the beautiful concept of the motion of a body on an inclined plane. I am sure you have enjoyed learning with us. If that be the case, like the video, share it to your friends, and most importantly, if you have not subscribed, subscribe to our channel.